All right, this is 5.4. We're talking equilateral and isosceles triangles. Let's jump right in. It wants us to use GeoGebra. It says construct a circle with a radius of 3 units. And they gave us an example right here. Okay, so they made this circle. They then created a triangle with points B and C being on that circle, right? So it had a radius of 3. So the side lengths are 3, and they give us that over on the side here. And then they talk about the angles, and it says angle A is 90 degrees, angle B is 45 degrees, and angle C is 45 degrees. Okay, so a good example here, just to kind of look at it. I'm going to go through GeoGebra here in a second, but first we're going to read part C. Recall that a triangle is isosceles if it has at least 2 congruent sides. So explain why ABC is an isosceles triangle. Well, it has 2 side lengths equal to 3, right? If B and C are on that circle, we know that the radius is 3. They're going to have side lengths of 3 no matter how much we move it. The side lengths will always be the same, okay? Or their side lengths will always be the same. And then it says, what do you observe about the angles? Well, we talked about the angles. I'm going to go through that a little bit here, a little bit more. Right here in part E, we have to repeat this. So I went into GeoGebra. I created their triangle with the circle. Okay, so radius is 3, and I double checked. Right, I found the distance, made sure that between A and C the length was 3, which it is. And the length from A to D is 3. Okay, so we know for sure we have an isosceles triangle. Right, when 2 sides are equal, at least 2 sides are equal, it is an isosceles triangle. But what I wanted to do is I wanted to show you what happens when I move points B and C around this circle. Okay, and I want you to pay attention to the angles. So let's move it to somewhere around here. What do you notice about these 3 angles? Well, I notice A is this big number, 109.4. Angle C is 35.3, and angle D is 35.3. Okay, so let's try another one. Notice angle D and angle C kind of always stay the same, don't they? They always stay the same, 68.9, 68.9. No matter how much we move these around the triangle, let's move, keep it within 360 degrees. 22.1, 22.1. Yeah, oh, I didn't want to move that. 51.9, 51.9. Can you even get these to match up? Look at that. Okay, 76.1, 76.1. No matter what, those 2 angles stay the same. Okay, and that's going to lead us right into this lesson. So we did part E. They give you a whole graph here. I think just moving those angles gives you a good idea of what we're kind of getting into here today. So, number 2 says, what conjectures can you make about the side lengths and angle measures of an isosceles triangle? Well, we know that in an isosceles triangle, okay, we have 2 sides congruent. What did we notice? We noticed that the opposite angles from those congruent sides were equal. So opposite angles from the congruent sides were equal. How do you prove your conclusion? I kind of just did it. We could write a whole long proof. I'm not going to. Okay, I'm going to get into some notes here. So in your own words, we're going to write these meanings down. Let me get my book out here. Find their definitions in the book so they can lead you in the right direction. All right, so let's So, when an isosceles triangle, when an isosceles triangle, and when an isosceles triangle has exactly two congruent sides, the two sides are the legs. Okay, for an example, if I drew a big triangle here, and I know that this side is congruent to this side, those are our legs. Legs, leg, leg. Okay. The vertex angle is the angle, the angle formed by the two legs. Okay, that's our vertex angle. Our base is the third side. And our base angles are the two angles adjacent. Remember, adjacent means next to. Adjacent to the base. Oh, base. Almost forgot an E. That was embarrassing. Okay, there's our definitions. Let me erase it so I can scroll down here. Remember, if you didn't get time to write that, you can always rewind the video. Some theorems I will be using today are the base angles theorem, and I want to talk about this. Okay, the base angles theorem. If two sides of a triangle are congruent, then the angles opposite them are congruent. Right? We talked about that. We found that out in our GeoGebra app. We know that when we move B and C here, those angles will always stay the same because they have congruent sides. So these two angles will always be the same. Okay, when we have an isosceles triangle. The converse to the base angle theorem, if they give us that B is congruent to C, so the angles B and C are congruent, then the sides opposite those angles, so opposite C is this side, and opposite angle B is that side, those are congruent. Okay, so understand those two things as we're moving forward. Get to know those two. Some corollaries that we'll be working with today is the corollary to the base angles theorem. If a triangle is equilateral, then it is also equal angular. Okay, so know that if all three sides are congruent, then all three angles will be congruent. And then the corollary to the converse of the base angles theorem, kind of a mixture of words there. If a triangle is equiangular, then it is equilateral. So if a triangle has three congruent angles, then we know that its three sides have to be equal. Let's go on to some examples here. Let's see if we can apply that knowledge that we just learned. That was a lot of info. Let's see if we can apply it. Complete the statement. Say which theorem you used. Okay. Well, if NJ, so find NJ here and kind of create a little mark right there. NJ is congruent to NN. Okay, there's our isosceles triangle. It's as big. It's the biggest triangle they show. Okay, we know that those two sides are congruent, NJ and NM. Well, then what do we know about the angles? Well, like we just explored, we know that the angle is opposite to those congruent sides. So this angle and this angle have to be congruent. So that's what we're going to say. We're going to say then angle J is congruent to angle N. Which theorem did you use? Well, let's scroll up and see that if two angles or two sides are congruent, then the angles opposite them are congruent. What's the base angle theorem? Right, so if I scroll back down here. It's the base angle theorem. Perfect. Number 2. If LM, where's LM? So find that. LM is congruent to LN. Oh, sorry, that's LN. LM is congruent to LN. My bad. I just mixed those two up. Then angle what is congruent to angle what? Well, again, we know that this is the same as the first one, so it's going to be the base angles theorem. Well, we know that opposite angles of this triangle. So we have which triangle? This triangle right here. We know that the angles opposite to those congruent sides are congruent. Well, go opposite those sides. It's this angle and this angle. Okay, so we know that angle M is congruent to angle, can I say just angle N? Can I say angle N? No, we can't. Why? Because there's 3 different angles going out there. There's this angle, there's this angle, the angle we already have, and then there's actually even this angle. So there's 4 angles. So make sure you don't just say angle N. Okay, we need to name this angle specifically. How do we do that? Well, we start at a point from the side that we're working with and the other side that we're working with. So we got to go from L to N to M. So angle L, N, M. We have to make sure that N is in the middle. Perfect. Let's try number 3. Okay, number 3 looks a little different. It gives us angles instead of side lengths. So if NKM, remember K is in the middle, so that's our angle that we're going to work with. NKM, which is right here. How do I know that? Because I worked from N to K to M. So we talked about that angle. It's congruent to NMK. Well, if I start at N and go to M and then to K, I'm working with this angle. Okay, so on this one they give us angles. Angles instead of side lengths. What theorem are we going to be using up here? Well, the base angle theorem gave us side lengths, so that's not going to be it. The converse to the base angle theorem gives us angles, right? So that's actually what we're going to be using. We're going to be using the converse to the base angle theorem. So that's what we're going to be using. I'm going to write it up here just because that's where we have room. And what did the converse of the base angle theorem say? It said that opposite sides, those congruent angles, are congruent. So we know that NM, segment NM, is congruent to segment NK. Then lastly, number 4. Number 4 says angle LJN, start at LJN, so that angle right there is congruent to LNJ, which is right here. It's that bigger angle. Try to find the triangle that that's working with. Well, it's working with this triangle here. And we're using the same thing, right? Converse to the, that's the base angle theorem. Yeah, I just abbreviated. Base angle theorem. Well, then what sides do we know are congruent? Well, opposite those angles, we know that LJ, so LJ is congruent to LN. Notice, I said LJ and not LK. All right, I'm talking about this whole side. Okay, and this whole side. I'm not talking about this. Okay, I'm talking about the whole thing. Moving on. Here's some good more, well, I can't speak. Here's some good extra practice for you. These are great problems. They made me think, which is always good. In exercises 5 and 6, find the value of x. Okay, well, how do we find the value of x? We have three equal angles, because these little marks mean that they're all equivalent. And we have one side length of 31. Well, if you don't know, scroll up. Okay? Or go in your notes and see when they give us an equilateral triangle, what do we know? We know that if a triangle is equilateral, then it is equiangular. Okay, well, all we know is that it's equiangular. Okay, and there's 5.3, corollary 5.3. If a triangle is equiangular, then it's equilateral. Okay, perfect. So we know that if all angles are congruent, then all side lengths are congruent. So x has to equal 31. Okay, number 6, they said that all side lengths are 12, which means all angles are the same. So this is 2x, and this is 2x. We have to find the value of x. Well, we know that 2x plus 2x plus 2x is equal to 180, right? Because three angles of a triangle, they all add up to 180. If we combine like terms, we get 6x is equal to 180, and that x is equal to 30. Another way we can do this. Another way we can do number 6. I'll erase. Another way we can do number 6. If we know that three angles are congruent in the triangle, then we know that each angle has to be 60 degrees. Okay, all angles in an equiangular triangle are 60 degrees. The 60 plus 60 plus 60 is 180. So we know that 2x has to equal 60. Right, and if we divide by 2, we get x is equal to 30. Okay? Same answer, different way to get there. I do not care which way you use, as long as you get to the correct answer. In exercises 7 and 8, find the values of x and y. I'm actually going to start with number 8 here, and I'll explain why. Number 8, take what we know. Well, we know that these two sides are congruent. And if this is x, then this has to be x. Alright? Well, we know that x plus 40 have to equal 180. Okay, it took x, and 40, and it has to equal 180. Combine like terms and I'm going to subtract 40 and combine like terms. So I get 2x is equal to 140. And if I divide by 2, I get x is equal to 70. Okay, so x is 70. Down here, what do I know about these two sides? We know that they're congruent, right? They have these little tick marks here. That means they're congruent. So we can set those equal to each other. We know that 2y, I'm going to right off to the side here, 2y plus 10 is equal to x minus y. Well, we know x is 70, so 70 minus y. solve for this, I'm going to add y and subtract 10, so I'm going to get 3y is equal to 60. And I subtracted 10, and I added y. And if I divide by 3, I get y is equal to 20. Pause the video. Try doing the next one on your own. Try doing number 7 on your own. This one's tricky. Try doing it. Okay? Number 7, we use kind of a combination of everything we've learned today. Number 7 is one of the more difficult problems. What do we have? I'm going to start by saying this. We have an equilateral triangle. Which means, what about the angles? I told you earlier that each angle is 60 degrees. Okay? Start here. If that angle is 60 degrees, it says that the bigger angle is 90, and we know that in here, this angle here is 30. Okay? From that information, we can find y. We can find y. I'm going to clean this up a little bit. I'm going to rewrite this so you can stay on track. If this is 30, we know that y and this angle, so y is the same, these two angles are the same, the ones I circled, so 2y plus 30 have to equal 180. If I subtract 30, I get 2y is equal to 150, and y is going to be equal to 75. Okay, halfway done. Now I just have to find x. Again, I have equilateral triangles. Okay, so if that's y minus 25, then this is y minus 25. Alright, and what do we know when we have two congruent angles? When we have two congruent angles, that means their sides are congruent. Okay, so x and that y minus 25, they're congruent. So we can set those equal to each other. We can say x is going to be equal to y minus 25. Well, we know what y is. We know that x is equal to 75 minus 25. And from there we get x is equal to 50. Okay, so a little extra thinking there. But great job taking notes.